In this section, we introduce a new probability distribution, and this is the binomial probability distribution. So a binomial random variable has the number of successes achieved in n trials as a Bernoulli process. So there are only two possible outcomes, success and failure. So we can't say that you would sell one house, two houses, three houses, as in the previous section. This is going to be you either sell houses or you don't sell houses. And we show probability associated with each of these values as 0, 1 to n. We're going to be using Excel, and I'm going to explain kind of why we use x minus 1 here, but you're going to always have an equal sign. Remember, every time you type something into Excel, but these are the formulas that you will use depending on what they give you. And then here's just some examples of words that they might use that you would then set it up accordingly. It's important to note here that this last number 0 is only for exact. Otherwise, it's always going to be that 1 at the end. So before we actually go into Excel and do these, I'm going to kind of explain why we have to do that. So if we look here, we've got a random variable n10. So we're doing this up to 10 times. The probability of success, P, is 0.54. Find the probabilities, I should say find the following probabilities. So if x is less than or equal to 4, we would put the x in right away, but let's think about what that means. So if we go to 10, that would be 0, 1, 2, 3, 4, we actually get all the way up to that 4. But if we were to do x is greater than 7, so that would be 8, 9, and 10. And so when we look at greater than, we do 1 minus. So that's kind of like saying 1 minus, right, the total minus 0, 1, 2, all the way up to 7. We're not going to include those. And then x is greater than 7, greater than or equal to 7. That would be 7, 8, 9, and 10. So here we would do 1 minus 0, 1, all the way up to 6 this time. And again, that's why we're looking at those kind of minus 1s here. And then between 2 and 8, that's kind of in the exact. So that kind of is the explanation is why sometimes we do the minus 1 and sometimes we don't. Hopefully that helps kind of clarify it for you. All right, let's take a peek here at these. So we want the probability that x is less than or equal to 4. So we're going to type in binomial distribution. And so we're looking at less than or equal to 4. So that's going to be 4. Our n is 10. Our p is 0.54. And 1. So the probability is 0.283. All right, we can try this next one here. So greater than 7. So let's look at the greater than. Now remember, it's greater than, so we're going to do 1 minus the binomial distribution of. Now it's greater than 7, right? So that was 8, 9, 10. So we can actually say 7 is included in this one. 7, we're going to 10, 0.54, and cumulative. And that's the probability. For C, x is greater than or equal to, so that's 1 minus binomial distribution. We included 7 originally, so we're only going to go to 6 this time, right? So greater than or equal to, we're only going to 6, 10, 0.54, and 1. That's the probability for C. Now, when we do a between, we're going to do binomial distribution range. Oops. Binomial distribution range, and our n this time goes first, 10, our p goes next, 0.54, and then x and y, we want to make sure we do the lower bound and then the upper bound, and that's the probability that x is between 2 and 8. And when we're looking at exactly here, so that's the binomial distribution of 3, 10, 0.54, and this time it's 0, and that is the probability that x is exactly 3. So we'll do one more example before you try on your own. So in the past decade, the use of technology has skyrocketed, with social media blooming into one of the most valuable methods of communication. People are turning to social media to stay in touch. According to this research, 68% of all U.S. adults are Facebook users. Consider a sample of 100 randomly selected American adults. So what that's saying here is that n equals 100 and p is equal to 0.68, and that means that that they are a Facebook user. The That's the success idea, is that they are a Facebook user. So what is the probability that exactly 70 Americans are Facebook users? So that's the probability that X is equal to 70. So that's binomial distribution. So 70, our number of trials is 100, 0.68 exact is 0. That is that probability. What is the probability that no more than, so that's less than or equal to, no more than, less than or equal to 70. So when we look kind of at our less than or equal to, we are going to do binomial distribution, and that is 70, 100, 0.68, and 1. And that's that probability. What is the probability that at least? At least is greater than or equal to 70. So this time it's going to be the probability of 1 minus, right, greater than or equal to 1 minus the binomial distribution, and this time it's 1 less, 69, 100, 0.68, and 1. So those are the probabilities. Go ahead and give this a try on your own, and there are the solutions. So in a binomial distribution, we calculate the expected value, variance, and standard deviation differently than just a discrete probability distribution. And we actually just use those by doing n times p. And what q is here, q is our 1 minus p, our fail, right? This is success and this is fail. And so that's how you calculate these. So when we do example 3, we're going to use that as well. So here we are told in the U.S. about 30% of adults have a college degree, 4-year college degree, so 0.03, have degree. And now we're talking about 5 adults are randomly selected, so our n is 5. So when we look here, we'll do that. Okay. So A, what is the probability that none of the adults have a college degree? So X is equal to 0. So that would be exact binomial distribution. We're talking about 0 have it out of 5 people we're asking with this is it and 0. That is the probability. What is the probability that no more than? So that's less than or equal to no more than 2. No more than 2, less than or equal to 2. So that is our binomial distribution of 2, 5, 0.3, and 1. And that is the probability. For C, what is the probability that at least 2? So 2 or more. Oops. Greater than or equal to 2. So greater than or equal to 2, that's the same as 1 minus less than or equal to 1. So that's going to be 1 minus binomial distribution. So we're talking about 1 this time, 1 less, 5.3, and 1. So now calculate the expected value, variance, so expected value, variance, and standard deviation. Now you can do this by hand, you don't have to use Excel, but the expected value is n times p. So our n is 5 and our p is 0.3. That's the expected value. The variance is equal to n times p times, now you can do 1 minus p, or maybe you can do that in your head, but that is our variance. And our standard deviation is equal to the square root of our variance. And so what that means is that we expect about 1.5 adults with a standard deviation of about 1 adult. Go ahead and give this one a try. Press play when you're ready to see the solution. And that concludes this section.